California is located in the western United States on the Pacific coast. Because of where California is on the map, it is faced with unique challenges. So, how do its geographical features contribute to its environmental vulnerabilities?
When we think of deserts, we typically imagine places far from oceans, where the sun is scorching and the land and rain is non existent. But what if I told you a surprising truth that deserts can and often will form along coastlines? This phenomenon may sound contradictory because, after all, oceans are massive sources of moisture. So, how can some of the driest places on Earth lie right next to them? This phenomenon can be answered through atmospheric circulation, ocean currents, and geography. Along the western coast of North America, cold ocean currents flow from the North Pole toward the equator. In the case of California, the California current brings cold water down the Pacific coast. This cold water chills the air directly above it, which causes the air to cool and its capacity to hold to moisture decrease. This means that even when the ocean is full of water, the air above it will stay dry, and when that dry air moves inland, it brings little to no precipitation. The cold water of the Pacific Ocean is only one of the reasons of deserts forming along coastlines. The prevailing winds in these regions often blow from the ocean toward land, which pushes this dry air inland. California is home to many mountain ranges that include Coast Ranges and the Sierra Nevada. As this dry air is forced up the mountains, it cools and sheds what little moisture it has on the windward side. Then, further inland, this air descends, warms, and dries out even more, creating what's known as a rain shadow. The effect of the rain shadow leads to extremely low humidity and very little rainfall, which are the ideal conditions for desert formation. This same rain shadow mechanism is responsible for several major coastal deserts around the world, such as in places such as Peru and Namibia. Deserts are a repeating pattern of cold ocean current and stable dry air and mountains. Now, here's where it gets even more critical, especially for California. These same dry conditions don't just support deserts, they also set the stage for devastating wildfires.
For wildfires to happen, there needs to be these three factors: oxygen, fuel, and some kind of spark. When we look at California's long, hot, and dry summers, we can notice that the abundant amount of dry plants causes kindling. These dry conditions are in action around summer and fall. Later in that time period, it has recorded that large winds move in. Santa Ana winds are super hot and dry. They swoop in from the inland deserts closer towards the coasts. These winds are extremely fast and also effective at initiating wildfires. Sometimes they can reach great speeds, and the fire embers can be seen miles ahead of the fire front. These winds further dry out the already dehydrated landscape and also fan the fire. These factors collectively make the fire risk dangerously high. Even the smallest spark can set off a huge wildfire because of how dry, hot, and windy the conditions get. With climate change getting more serious every year, it leads to more extreme California summers, which then leads to even bigger risks of wildfires. In a nutshell, the dry and arid coasts of many places like California can be linked back to the least suspected of places, the ocean, and its cold currents which dry out the surrounding air, leading to dry descending air inland and rain shadows. Those factors then lead to dry environments on the coast, which puts the surrounding areas at risk for wildfires. Just like any other place on Earth, California faces climate change, but it is affected in many different ways. Climate change as a whole is a big positive feedback loop. This means that initial changes in the climate will get more and more severe and amplify as time moves on. This also means that seasons will be more drastic in their weather conditions, bringing hotter and drier summers every year while intensifying weather patterns. In the context of California, we can see the greatest impacts during its summers, which, as mentioned earlier, get continuously hotter and drier each year as the positive feedback loop intensifies. California has experienced increased droughts and wildfires these past years due to the effects of climate change. The World Weather Distribution states coastal Southern California has a Mediterranean climate with fire adapted chaparral shrubland grasses and oak trees. Wildfire is a natural part of the local ecosystem, with some species even depending on it. Wildfires are typically largest from July to September due to low fuel moisture caused by lack of precipitation in summer, high temperatures, and low humidity. However, some of the region's most destructive events occur in fall or early winter due to the arrival of the Santa Ana windy season. As summers worsen each season, the risk of wildfires becomes more and more threatening, but that's not the only thing climate change has altered. Along with more dramatic weather patterns and wildlife risks, we also see a rise in droughts. The warming temperatures and lower rates of rainfall means longer periods of droughts or even extreme droughts. The causes behind climate change are largely affected by human activities, more specifically our emissions of greenhouse gases through the usage of fossil fuels. The diagram from the EPA shows recent trend in global emissions of greenhouse gases and the concerningly steep line showing our increase of fossil fuel industry from 1850 to 2010. This trend only continues to the modern day world, continuously negatively impacting the Earth's climate, weathers, patterns, and environments.
Now, let's switch focus onto tectonic plates and faults. The Earth's outer shell is divided by tectonic plates which are constantly moving and interact at their edges in different ways, creating different kinds of plate boundaries. California is heavily affected by transform boundaries, which are two tectonic plates sliding past each other horizontally, which causes boundaries such as the famous San Andreas Fault. The Pacific Plate moves northwest, while the North American Plate moves southeast. This movement is what causes much of California's earthquake activity. According to the National Earthquake Information Center, it's reported that each year, California generally gets 2 or 3 earthquakes with a magnitude of 5.5 or more, which is large enough to cause moderate damage to structures. The prevalence of divergent boundaries and convergent boundaries is not seen in California, but to review, divergent boundaries occur where plates move apart from each other, and convergent boundaries are where plates collide and typically one plate is forced beneath another in a process called subduction. In order to further understand the risks of California's earthquakes, it's important to talk about 3 different types of faults: strike slip, thrusts, and normal faults. We can see all 3 of these faults around California, and they all form differently. For example, when looking at strike slip faults like the San Andreas Fault, we can see that this fault has 2 landmasses sliding past each other horizontally. Similarly, there are thrust faults which occur in areas such as the 1994 Northridge earthquake in Southern California, where the crust was being compressed and then blocks of rock were forced to push up over another at an angle. Lastly, we have normal faults, which occur in areas where the Earth's crust gets pulled apart. In these normal faults, the hanging wall moves downwards relative to the footwall. Each of these fault types reflects different types of tectonic plate movements and shows why California is such a hotspot for seismic activity. To recap, the unique geography of California means it's challenged with wildfires due to its coastal desert, earthquake because of its orientation in relation to tectonic plates, and droughts because of climate change. The negative impacts of human activity can be witnessed all across the globe aside from just this state, but it's not too late to change things for the better. Spreading awareness about this issue alone is a call to action, and as we continue to advance scientifically, it helps us understand the natural world around us and how to save it.